Graphing radicals. Alright, so the first thing you need to do is find the domain. This is especially true when you have square roots. Okay? So to find the domain, what you have to do is basically find out all the values for x in which you will get an undefined answer. Right? So in this problem, okay, once x gets larger than 3, we get undefined because if we plug in, say, a 4 into here for x, that'll give us negative 16 plus 12. That gives us negative 4. And we can't have a negative under the square root. Okay? But anything less than that, the square root becomes positive. So that means that the domain is negative infinity to positive 3. Right? Because positive 3 will get negative 4 times 3. That gives us negative 12. Negative 12 plus 12 is 0. So square root of 0 is 0, so that's still good. But just, if you do 3.1 or 3.5, you're going to get a negative under the square root, and that's bad news. Alright, so our domain is negative infinity to 3. Okay, so now that we have our domain, okay, and we set up a table with some nice x values, okay? Alright, so I started out trying to give you some nice values. But especially with these, you want to have as many points as you can, because this is not a normal kind of graph. Alright, so the more points you have, the better your shape is going to be, and the more accurate it's going to be. Okay, so what I did was I just picked some points and I substituted them. Okay, hopefully you should know how to do that by now. Okay, and lastly, we need to plot our points and then connect them to the best of our ability. Alright, so the first one's 3, 1, then 2, 3, negative 1, 5, negative 6, 7, and then I just added 2 more. Now these are decimals, but that's okay. Alright, so that one goes there, and this negative 2 one goes here. And now I connect them nicely, and you get this kind of curve. Okay, it should look like half of a sideways parabola, because generally speaking, that's what these kind of graphs look like. Okay? Alright, and that completes our problem.